Hello, math buddies. Today we're going to learn about combination. I am Cherdons and welcome to Math TV. Let us begin by defining combination. Combination is an arrangement of n objects with no repetition, and the order is not important. I have here three colors: red, blue, and yellow. There are six possible arrangement of colors by 2. We have red, blue, and blue-red, blue-yellow, and yellow-blue, then yellow-red and red-yellow. Bear in mind that order is not important when it comes to combination. Red, blue, and blue-red are considered as one combination. The same goes with blue-yellow and yellow-blue, and yellow-red and red-yellow are the same combinations. Therefore, there are only three combinations of the three colors red, blue, and yellow taken two at a time. So, changing the order of objects doesn't create a new combination. Combination of n distinct objects taken r at a time is given by the formula n factorial divided by quantity n minus r factorial times r factorial, where r is less than or equal to n. N is the total number of objects and r is the number of objects taken r at a time. In other books or references, combination can be denoted in different ways. C and R, or C quantity n comma R, or simply quantity n on top and R at the bottom. Number of combinations of objects taken all at a time is always equal to 1, meaning your n is equal to R. For instance, combination of 7 objects taken 7 at a time, combination of 120 objects taken 120 at a time, or combination of 500, 500, combination of 30, 30 are all equal to 1. Let us proceed to example number 1. Evaluate the following. Combination of 7 objects taken 4 at a time. Our formula is equal to n factorial divided by quantity n minus r factorial times r factorial. Plug in the value. Combination of 7 objects taken 4 at a time is equal to 7 factorial all over quantity 7 minus 4 factorial times 4 factorial. Simplifying it, we have 7 times 6 times 5 times 4 factorial over 3 factorial times 4 factorial. Cancel out 4 factorial. We left with 7 times 6 times 5. That's 210 divided by 3 factorial, which is equal to 6. So 210 divided by 6, it is equal to 35. Next, we have combination of 13 objects taken 7 at a time. Our formula is equal to n factorial divided by quantity n minus r factorial times r factorial. Plug in the value. Combination of 13 objects taken 7 at a time is equal to 13 factorial divided by quantity 13 minus 7 factorial times 7 factorial. Simplifying it, we have 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial all over 6 factorial times 7 factorial. Cancel out 7 factorial. We left with 13 times 12 times 11 times 10 times 9 times 8, which will give us 1,235,520 divided by 6 factorial, and that is equal to 720. So, 1,235,520 divided by 720 is equal to 1,716. Example number 2. Mrs. Reyes, a mathematics teacher, prepared 20-item questions for recitation. How many ways can a student select 3 questions at random? There are 20 questions. The value of n is 20. The value of r is 3. That's the number of questions the student can select. Our formula is equal to n factorial divided by quantity n minus r factorial times r factorial. Plug in the value. Combination of 20 objects taken 3 at a time is equal to 20 factorial divided by quantity 20 minus 3 factorial times 3 factorial. Simplifying it, we have 20 times 19 times 18 times 17 factorial all over 17 factorial times 3 factorial. Cancel out 17 factorial. 20 times 19 times 18 is 6,840 over 3 factorial. That's 6. So 6,840 divided by 6 is equal to 1,140. Therefore, there are 1,140 ways the student can select from the 20-item questions. Example number 3. In Mathematics Club, there are 10 boys and 6 girls. Letter A. In how many ways can a committee of 5 students be selected? And letter B. In how many ways can a committee of 2 boys and 4 girls be selected from the group? Let us solve letter A. We have 10 boys and 6 girls. 10 plus 6 is 16. The value of n is 16, while r is 5, because we need to select 5 students. Our formula is n factorial over quantity n minus r factorial times r factorial. Substituting the value, combination of 16 objects taken 5 at a time is equal to 16 factorial over quantity 16 minus 5 factorial times 5 factorial. Simplifying it, 16 times 15 times 14 times 13 times 12 times 11 factorial all over 11 factorial times 5 factorial. Cancel out 11 factorial. 16 times 15 times 14 times 13 times 12 is 524,160 divided by 5 factorial, which is equal to 120. So, 524,160 divided by 120 is 4,368. Therefore, there are 4,368 ways. For letter B, in how many ways can a committee of 2 boys and 4 girls be selected from the group? We have 10 boys. The value of n is 10. Then you need to select 2 boys. The value of r is 2. For girls, we have 6 girls. The value of n is 6. Then we need to select 4. So the value of r is 4. Our formula is equal to n factorial divided by quantity n minus r factorial times r factorial. Substituting the value we have, for boys, combination of 10 objects taken 2 at a time. For girls, combination of 6 objects taken 4 at a time. Using fundamental principle of counting, we will multiply them. 10 factorial over quantity 10 minus 2 factorial times 2 factorial times 6 factorial over quantity 6 minus 4 factorial times 4 factorial. Simplifying it, 10 times 9 times 8 factorial all over 8 factorial times 2 factorial times 6 times 5 times 4 factorial all over 2 factorial times 4 factorial. Cancel out 4 factorial and 8 factorial. 10 times 9 is 90 over 2 factorial, which is equal to 2, times 6 times 5 is 30 over 2 factorial, which is also equal to 2. 90 divided by 2 is 45 times 30 divided by 2 is 15. 45 times 15, it is equal to 675. Therefore, there are 675 ways of selecting 2 boys and 4 girls from the club. Example number 4. In how many ways can a set of 3 cards be chosen from a standard deck of cards? Standard deck of cards means you have all or complete counts of a regular playing cards from A to King. The standard deck of cards is 52. The value of n is 52. Then we're going to choose 3 cards. The value of r is 3. Our formula is equal to n factorial over quantity n minus r factorial times r factorial. Plug in the value. Combination of 52 objects taken 3 at a time is equal to 52 factorial all over quantity 52 minus 3 factorial times 3 factorial. Simplifying it, 52 times 51 times 50 times 49 factorial all over 49 factorial times 3 factorial. Cancel out 49 factorial. 52 times 51 times 50 is 132,600 over 3 factorial. That's 6. 132,600 divided by 6 is equal to 22,100. Therefore, there are 22,100 ways of choosing 3 cards from a standard deck of cards. I hope you enjoy our discussion for today. See you again for our next lesson. Thank you. Have a nice day and God bless everyone.